sports day, so I just leave that alarm on, and then I ask 3B, do any of you need to leave? But thank you for letting me know. I just,
yes.
right? Because I can't keep track of it now. So I just leave that alarm on my phone, and yeah, just whoever, if you want to, like, you know, pull one over on me and you leave class 10 minutes early, you're just missing time to do math. But I had the list of who was on what teams, but then it changed. So, all right, so in 107, guys, you have what is called a two-way table, because it's talking about two different things, right? And sometimes we have two-way frequency tables. What does frequency mean? It can be frequency of like a radio signal, but that's not what we're talking about, Val.
Like how many in each like category?
Yeah, like how many, right? Frequency, how many? So we can see, hey, unnecessary. We can see that our categories are sandy soil versus clay soil, and then our height categories. Anyone notice anything weird about height categories? Anything like suspicious, awkward, Liam?
I mean, it goes from 0 to 3 and then like 3 to 4, like kind of like skips.
Yeah, they're not.
It's not a pattern.
They're not evenly distributed, right? So they've chosen these maybe because, like, you know, 0 to 3 foot tall corn isn't really that, like, you're not getting much off that. There's not much actual corn. Like, if the plant's only that tall, you're probably not getting much actual corn. Yeah, and then this, like, is such a, how much corn is actually 7, 8 feet tall? Maybe that's why they didn't make that any wider. They could have honestly said, like, 7 to 9 if they felt like it, even if none of them were above 8 feet. But yeah, that's kind of interesting. Colin?
They have like overlapping numbers.
What do you mean they have, like, overlapping numbers?
Like there's 0 to 3 feet and then there's 3 to 4 feet.
Yeah, so if the corn was exactly 3 feet or exactly 4 feet, you'd have to have chosen, does it fall into the lower category or the upper category, and stick with that. What other data distribution or data displays did we have to choose? Do we drop into the bin below or bump into the bin above? I'll say it louder. Histogram, right? So that's when we had to decide. So, like our bar graph, right? But a histogram are bars that are next to each other because the ranges run right up against each other. So what you're going to do in part C is read these directions, create a new table full of percentages. So go ahead and take a minute, make that happen. You get almost 107, go ahead and move on to 108. This helps make sure you're starting correctly. Read it and make sure you're starting correctly. I'm probably going to need you to put that away because the noise is really distracting me. Do that? Who's they? And what does that relate to what we're doing right now? You're letting your brain go too far, man. You're going down that rabbit hole. I need you to do what we're being asked to do right now, which does not need a three-dimension table. So whether or not they exist doesn't really matter. Wait, no, they of course the 3D table? It's right here. 3D. But so our labels, guys, are we waiting for like an individual invitation? Do I need to like print out invites and invite you to the math party? We should start drawing the exact same table that they have, except instead of filling in the numbers, we're going to end up having to calculate the percentages. So our table's going to have the same labels. Our table labels?
Label tables.
Well, no, that would be a table discussing labels. You know, like how many labels were red, how many labels were blue. Guys, my goal is that we have time for homework at the end of class. But I still got some people that are just staring. Like, I don't even think you're reading. I think you're just staring. You really don't have to have a book or the ebook if you can see the screen. But I know for some of us it's kind of far away. So that's why I wanted us to get those out. So it tells us the height of the bar for 0 to 3 feet will be 9%, and they show us how to calculate it because we are doing row totaling as opposed to column totaling. So in two-way tables, you can either pick. We're working with the total of the total, which would be our 2,500. Or we could be working with row totals or column totals. So this 1675, that box right there, when you make your percent table, this box is going to be one of our 100%. Because we're going to have 100% of our sandy soil and then 100% of our clay soil. Because we're deciding that we're doing row totals instead of column totals or total total. We got three options when we go to do this. So, for example, the height of the bar for 0 to 3 feet will be 9%. So height 0 to 3, so it's that 150, right, divided by that 1675, because we're analyzing what percent of this row is there. And then we'll do what percent of this row is there, which will be more than 9%, right? What percent of this row is there? So we're going to ignore this bottom part, actually, for this first thing that we're being asked to do.
Okay, so
Okay, guys, if you read the directions, it tells you the third row, unimportant. What do you mean the division? I can't even see your calculator because you're kind of pointing. Yeah, so that percent goes in that box. I'd give it 2 decimal places, maybe 1 or 2 at a minimum. It's 11 now. It's 11.94. That's real close to 12. So you can round it up to 12% if you really want. But realize you may not total up to exactly 100% if you rounded some of them. Yeah, sometimes they've changed the ebook. That's because this is a typo. So in your ebook, they fixed the typo. If you notice up here, they skipped from 6 to 7. This should have been 6 to 8. They fixed it in the ebook. Your actual book got printed before anybody realized it. Right, so if you're using the ebook, you'll see it correctly. If you're using the actual book, honestly, you could just write a 6 over. Oh, they did fix it? Aha.
Wait, in the book, just right over.
No, because actually it's right in the book. Most of the time the typo still exists in the book, but apparently they caught this one before they published. But they didn't this. These slides are made off one of the original ebooks because that's what got downloaded and then I make my slides off of. You seem stuck. That's all. You don't even have a rectangle drawn on your paper. So can we at least start with drawing a rectangle big enough to make into a table like what they have? And then can we put the labels that they have? Can we at a minimum do something? Otherwise we can't do something. We're probably sick and need to go home. It's better. No, it's not. I will race any of you. Google calculator is not fast. I'm using a handheld calculator.
I'm just typing in the search bar.
It's,
And it shows it right here.
Same thing.
I'm still telling you, a handheld calculator is faster.
Yeah, but I read it.
Argue me why.
Because if you're faster with the keys, you're faster with the calculator.
Guarantee if you practice on a handheld, the same speed or faster. By the way, I went on a trip this weekend, so I did not do any grading. So if you turn in your homework that was due on Friday, today, no one will know it was late. On Friday when it was due.
18, 18, 18, 18,
Most of it? Well, if you have any more to turn in, get it turned in. Because we've identified most of the time you just forget to turn it in. Not that it's not done.
Mr. Hudson, there's also you can convert it to a percentage on the calculator.
Yeah, I I know, the handheld calculator is better. I think you're supporting what I say.
Stand up, join this side.
Oh, I am definitely
So am I.
That's such a reason thing to do.
So they said the third row is unimportant because we're doing row total, and that third row was just the totals of the columns. So we don't need that anymore. And we're going to fill in our table with percent value. Now you could fill in your table with the decimal values of the percent. That is 100% up to you. See what I did there? So let's get some random card action going. Bradley, since they already told us that 9%, we should probably move on to one of the other ones. You want to go across the sandy soil, or you want to give me the other 0 to 3? All right, so sandy soil 3 to 4 feet. What'd you have there? Yeah, so this should be 12%. Guys, this should be done on your paper. Like, if you're just now getting to this point, you've wasted a lot of time. Val, what about this next box? 4 to 6 feet.
34%.
34%. And then if I fix my 7 to a 6, because that's actually a 6. Nick? 6 to 8.
6 to 8. 45%.
Yeah, 45%. And depending on how we rounded, this should total up to pretty darn close to 100%. Yeah, if you got 99, you just, that's because of rounding. So then, Rin, what about clay soil 0 to 3?
About 27%.
Yeah, 27%. Lucy, what about 3 to 4 feet?
18.1%.
Yeah, 18, or if we just round that down to keep this a bit cleaner. Or sorry, 18.1, or if we round it down. Bryson, what about our next one?
I need that one.
Can we do it? What would we divide to? Like, what math would we do to get it?
I usually do the total, which would be 825
Yeah.
times.
Wait, you do what?
I'll multiply it by like the decimal. I'm kind of.
There's a much more efficient way. We need to tag somebody to help you. Just hold on. Stop what you're doing. Let's see if we can get some help. You pick. Because I guess we'll.
Mason's giving me the stairs, so I think he wants to.
Yeah, I can't quite tell what's going on with Mason. Do you want to pick someone to help you out?
So, ideally, you would divide the like partial or like a little bit of it by the total.
Part divided by whole. Guys, calculating percentages is not a guessing game. It's part divided by whole. Like it told us in C. That part of the problem that I said, make sure you read this. Cough, cough, Bryson. Make sure you read part C and it tells you what to do. So that gets us 24%. So, still no Soph. Soph, feel better soon. I am actually recording. There, you got to show.
She's not
Any-
a quiz.
Anyone want to pick a secret word that she'll never, Caden, give me a password.
No, I'm gonna raise
Avocado on
Okay, avocado. There
Yeah,
we go, Soph.
yeah.
Come back and tell me avocado.
She's a millennial.
All right, and then 30%. And what should be over here in the total? 100%.
Say avocado now, so.
You had what?
I just found it up to the last one.
Are you saying I got something wrong?
No, 99%.
Oh, yeah. Yeah, if we're getting 99, it's because we rounded a couple things
So
down.
type avocado.
Hey, guys.
right now.
We're moving on.
Below.
We're moving on, or I'm never doing that again. If you ruin it, you ruin it for the year. I'll try again next year. We're moving on. Any questions on calculating those percentages? All right, so now we need to see if we remember how to make bar graphs. So now you've got these directions in your book or in your ebook. Dive into it. You guys know how to read directions and follow them? I feel like too much of our classes is like me leading. You don't need me to lead this. You got it. Similar to a histogram, but not. Right? Because the bins are not what? The bins are not. Rain's trying to think of the word. They're not equal, right? The bins are categories. These are not equal. To be a histogram, these would need to be equal. So we're just making a bar graph here, similar to a histogram, but just a bar graph. Vertical axis will be our percentages. That's not green. So does our vertical axis need to go up to 100%? No. It only needs to go up as high as our values do.
It only needs to go up to 50.
Well, depending on whether I'm doing sandy soil or what's the other independent variable?
Clay.
Yeah, the clay soil. So we're going to have two bar graphs. Sandy soil and clay soil. We're going to have two bar graphs. Sandy soil and clay soil.
Is the bar graph the one that goes up? Is the bar graph the one with rectangles? Yes.
The bar graph is the one with the bars. You are correct.
Wow. Really? The bar
Well,
graph?
she said the rectangles. I'm just being real, like oversimplifying. So down here should be those height categories. Over here should be our percentages. I'll break that up in a moment. So our first height category, 0 to 3. And it doesn't have to be right against the y-axis, right? I can just put this somewhere above it. But this is going to go up some height to whatever percent it needs to. This is where graph paper is way better than me just working on a blank space. Any other questions on how to get rolling? So I want to make sure I give you plenty of time to do this. What I would love is if somebody loves their bar graph enough, you want to share it with the class, and we can just put it under the camera. We wouldn't want our bars to be right next to each other because this is not a histogram. You're fine. You don't have to change it on this one. But when you go to make the clay soil one, try to leave a little gap between them. Because you don't want your bars to be right up against each other because this is not a histogram.
Wait, can we just make them on the same graph?
Yeah, absolutely. You just don't want them to be up against each other because, like, this isn't a histogram, and that would make it look like a histogram. You should have these percentages written down, but in case you didn't get all of them, so sometimes I try not to bug you like way too much. Like if sometimes you're having a bad day or way too tired from the weekend or whatever. If you need help knowing how to do this, please call me over. Otherwise, I assume that maybe just today is not a great day and maybe we're working a little slow because of that, or like maybe we're just choosing not to do this because we know how to do it and our brain is just like. If you need help, please call me over or ask a friend. Otherwise, I'm just giving you time to do this. textures to their bars. So like this one's polka dotted, this one's striped, this one. You can like delineate. Now you don't really have to fill them in with anything. So colors, I'll take colors. Technically, since apparently that's one of our favorite middle school vocab words, technically this should be two totally separate graphs. Even though they're sort of analyzing the same thing, even though they're sort of using the same height categories, they should really be two totally separate graphs, each with a label of sandy soil, clay soil, like whatever the graph is showing.
I have them like stacked on top of each other.
As long as they're separate. So we would not want to do this because that kind of skews what things look like. We would legit want two separated graphs. But that's why we're practicing, right? To make these mistakes when it's safe and doesn't really make a big difference. Stay tuned. Now wait, what are the labels of these axes? What's the label of the graph? What's the, if you got time to put your head down like take a nap, you got time to put labels on it. Nice. Yeah, because we only got that high. It's interesting like how much taller that one looks compared to that one. But yeah, that tells us, I mean, in sandy soil, what are we most likely to have happen versus in clay soil. Yeah, like guys, we can start to kind of use these visuals to like be able to make a statement about what we just saw. Anyone already like get enough graph that you want to make a statement about what we see? And I think most of us are still doing our second one. Adele, do you want to share your graphs while you make your statement?
Sure.
If you don't mind, I would love to. All right, Adele, what statement do you think you're realizing based off this data, at least?
Sandy soil tends to produce the most
Sandy soil, Adele is saying sandy soil tends to produce tall corn plants. I'm kind of tweaking the words a little bit. Versus, what could we say about our clay soil then? Clay soil is kind of just like,
nothing to say nice, I won't say it at all.
yeah, it's like pretty consistent of like distribute. Not that that's a good thing, but it's a pretty evenly. Now wait, our tallest bars are, well, still 6 to 8's your tallest bar,
Not by
But-
much.
but not by much, right? So even though this is your highest frequency, but not by much, right?
Not the tallest one.
Interesting.
Sandy soil is better.
Yeah, sure seems like sandy soil is. Anyone think of a reason why? I know most of us probably haven't grown corn before, but can anyone think of a reason? Zach?
Because sand isn't like one thing, so there's like air able to get like down in there.
And what else can get down in there?
Water.
Yeah. Air, water, and even bugs. Like, bugs are good for plants. I mean, certain bugs are bad, but, you know, it's good for plants to have interaction with different bugs and the air and the water. All right. So, guys, a good graph would look exactly like Adele's, or at least have the same traits. Evenly spaced axes. At least when that matters. Does it matter if I evenly space out my x-axis? Not really, but the bars being the same size would be a good thing. Even though this range is not equal to that range, it would be good if our bars were the same width as each other, just because it would look nicer. Evenly spaced axis type. Now, what is, and it's because I took it away from Adele so quickly, what are we missing? Actually, not, I guess we don't really. The only labels, if I was trying to be real nitpicky, we could say like percent of clay soil, and we could say like height of the corn. I mean, you could have a little bit more, because if you just put this in front of somebody, would they know we're talking about corn?
Yep.
Not necessarily, right? So make sure that your graph communicates everything you want it to. But it's because I took this away from Adele so quickly. All right, New task. I don't know if I've shared this before or not, but my brother, unfortunately, is diabetic. He has had like adult onset diabetes. I want to blame Mountain Dew. But it's pretty hard to blame just like one thing. But yeah, he drank a lot of Mountain Dew. I want to say that's why. So we're going to take this data from the CPM Diabetic Institute and try to turn it into a relative frequency table. So even if you're still making your bar graphs, pause on that for a moment. A relative frequency table needs to have row totals, column totals, and the total of the total. So we need to copy this onto our paper, but also, so hold on, because you might want to like not just copy it exactly how it looks like. We need to copy this, but also make space for totals out here. Make space for totals down here. And make space for the total over here. So your bottom right box out here will be the total of everything in the table. Right out here will be the total of everything in the table. So take a couple minutes, copy this down, and total up everything. Then we'll do the next thing with this. Okay, need more paper, or are we going to flip? You use the back of your paper if you want, or you can get more. Huh? Yeah, you're right. You know why pounds is LBS? Goes back to actually the original word was lumber. Yep. I forget which like culture or society or whatever that came from, but that I looked it up one day because we were in class and curious about why is it LBS.
I mean,
I think everyone's
yeah, science, stuff, like,
Math class is always real weird about that. In the beginning of last year, we Googled why W's were called W's and not double V's.
Double V, yep. Why not double V?
the lowercase version looks like two U's. Only the lowercase version.
Unless you have a different handwriting. In that case.
Hey, so because I know some people are quicker than others, then our task will be like we had just done with the percentages. But guys, listen. We're going to turn this into a relative frequency. Currently, it's a frequency table. It's a two-way frequency table. To make it relative, we have to, get it some cousins and brothers and sisters. No. To make it relative, we need to turn it into the decimal percent values. So like the rate, right? So we're going to make all of our totals. But then when we go to calculate the percentages, guys, again, if you read the directions in your book, it walks you through this. But we're going to now be dividing by the total. The total is now going to be our denominator. Okay, so the total. But I need to total up my table first. Good thing I did this last year. Don't need to use a calculator. Well, whenever I first did this and wrote it down, probably. I mean, had to, no, but did it save me time?
Probably.
So if you want to check your totals, in case you were doing it mentally and just want to double check. But I need some help because apparently I decided not to write this down last year. What's our total? It should be the same as whatever these three add up to, or whatever these two add up to, because they should end up the same, Caden.
I think your low blood sugar total is wrong. I think it's 187.
Yep, I can't read my own handwriting. That's legit what just happened. Now that you say that, I'm like, oh, okay, that's a 7. Yeah, that'll work nicer for, is it 1,000? Yeah, that's what my gut was saying. It's 1,000, right?
I mean, it tells you.
Oh, I stand corrected. According to CPM, we're allowed to use the percent values or the decimal values. So up to you. But Mighty Bar, we should either have 20% or 0.2. Up to you if you want to use the rate values or the percent values. This will not be 100%. None of these will be 100%. Except for out here. So now we're making a new one with percentages. I'm surprised no one's like said anything like this yet, but a lot of times at a point when we've been doing a lot of writing on the paper, somebody says, couldn't we just do this on a computer? Couldn't we like get the computer to do this? Yeah. But we would have to tell it what to do, whether we want it to row total, column total, total. Like we gotta understand what the differences are before we would know how to tell the computer what to do.
Yeah, I think like modern mathematics is more of learning how like to tell the computer what you want.
Yeah, pretty much. I agree with you. I guess we'll go with percent value so the decimal feels a little cleaner.
Thank you. Yippee.
Please don't finish that sentence. Most of you probably do not know, and that's a good thing. Exactly.
I didn't hear what he said.
Exactly. This conversation never happened. It was a non-versation.
I don't even know.
Look at me.
Well, it's either you or Bryson that started the sentence.
Was it?
And I don't know that we're gonna have time to turn these into bar graphs, but we can probably like analyze the percentages here and think about what the bar graph situation would look like. So my low blood sugar totals up to 20, almost 20, and almost 20.
57%.
I was about to say, I know it's going to be almost 60, but 57%, you said? What? 57.1? So, I mean, the other percent is just going to be what's left over, right? And guys, again, this is where we could use the word complement. It's the complementary percentage. And what instead of like complementary angles adding up to 90, complementary percents should add up to 100.
So 42.9.
So 42, and that's like our what we think should happen. So let's double check it with the actual other values.
Oh, Bryson.
So what percent would we have here?
12? No, wait, I completely lost.
Chop off the zeros. Yeah, I think 12.
Oh my god, that.
Well, because it's over 1,000, right? Over 1,000
It is 1,000.
is not. Wait, are these? I've been waiting for someone to say these aren't right. These would go if I was totaling with column totals. If I did the math by column totals, so guys, if you got these numbers, they're wrong. Hopefully you didn't get them. If you blindly copied them down, quit trusting me. Well, okay, I want you to trust me most of the time. But don't blindly trust me. Check my math.
I was originally confused, and I was like, oh, maybe
Well,
that's
because
the
I'm
truth.
having to pick which ways we do this. We could do this a bunch of different ways. if we column totaled,
It would be like 3%.
and this might be a lesson that carries over to the next day,
It's 3%.
this should be 3 because 30 out of 1,000. This should be 9 point. We don't even need a calculator, guys. 6.6. I was gonna see how many numbers I could put up here before somebody stopped me. By the way, see me later. You get a sucker.
Yeah, good job, Isaac.
So 42.9 definitely is not true.
May I please have Stella Hickman to the Perry office? Stella Hickman. Thank you.
I have a feeling most of us weren't really paying close attention. My hunch was just sadly correct.
I kind of just decided, like, you know what? He's the teacher.
Yeah, I
Same,
just
I
did
did
the
that.
That's because I haven't really done
I
numbers
got
in a
different
while.
answer and I was
So I
like, oh, I
intentionally
probably did
write
it
something
wrong.
down.
I wrote down the
I've kind
entire
of learned from my previous years of school to, like, always trust the teacher.
But not blindly, because we make mistakes.
But last year,
Right.
but last year she would yell at you.
Yeah,
if
Mrs.
you
Freer
tried
would
to
scold
correct
you.
you.
If you
No.
got it, like if you
I
said
think
she
it's
got
great.
something wrong, she would scold
Dang
you.
it. See, I can't get used to this schedule this year. Hey, we are going to have to carry this over tomorrow, but here's what's probably going to happen. We're probably going to finish up this lesson tomorrow, make sure this makes sense of like what we were trying to compare. Please do not lose this paper. Please keep this at least till tomorrow. Then we'll start Jenga tomorrow and then finish it Wednesday. Right? We'll probably just make, because Wednesday I didn't know what we were going to do anyways. So we'll probably just make Jenga take like a day and a half. So have a great day, guys. Get out of here. Sorry, we ran out of time even quicker than I thought.
What was the
you now my math's so messy.
This class ended at 2:52. And then the next class ended at... No, crap. What am I misremembering? Ask me sometime. I bet I still have it in like an old plan book.
Yeah, she did not like it. 'Cause it's not